press record. I didn't press record, bro. Okay. Now it is time to start. Not yet. 3 minutes. 3 minutes. We gonna give them 3 minutes. 3 minutos. So guys, today we're gonna be learning how to do math, and so I'm gonna teach all of you on stream how to do a certain equation or a certain aspect of math, I should say. It's not easy. Well, it is pretty easy, but yeah. Do it, come on and do it, do it. I'm streaming. Okay, we're gonna start. We're gonna start very soon. Very soon. Who's this? Oh, I know you. Okay. Okay. 2 more minutes. 2 more minutos. 2 minutos. 2 more minutes. Guys, we're gonna start very soon, I promise. I pinky promise. Pinky promise. Oh wait. Okay guys, thank you for my 2 viewers, thank you so much. I appreciate the love. Y'all gonna love what I got for y'all today, man. Very nice, very educational, I should say. So when it hits 5:05, I'm gonna do like an intro, and then we can start from there. Oof. I ate too much, bro. Eating too dang much. I gotta chill. Play skate. We can play skate right after I teach math. Right after I teach y'all math. Sour Patch, we can do it. Bro. Okay. I'm a skate 3. I'm a skate 3 prodigy, bro. I'm so good at skate 3, bro. I'm like absolutely cracked at skate, bro. I love that game so much too. It's such a fun game to play. Okay, I honestly have a really good time while playing it, bro. Chat, do I look like Pikachu? Do I look like Pikachu? Can I think of Pikachu? Nah, I'm just playing. 5:05, guys. We will now officially start math class. Class is in session. Like 5 more minutes. Nah, I'm just playing. 1 more minute. I'm gonna sign into something really quick. It's taking forever. Do it. Come on and do it. Do it. You can do it. Okay. Enough playing around. Wrap it up. Why are you wearing a banana costume, lol? Okay, I won't wrap it up, but I'll peel it down. No, I'm wearing the banana costume for my project. This is my math project, math video project. So I hope y'all love it, bro, cause I'm gonna love it too. Y'all ready? Are you guys ready? I'm gonna start rolling everything out now, like for real kind. Okay, we're gonna play the theme song. I'm gonna play the theme song. Y'all ready, bro? Y'all ready? Do it. Y'all can do it. Okay, enough dancing. Okay, let's actually get into the math. The thing I'm really here for. You can do it. Okay, without further ado, good morning, class. My name is Alvis. Wait, 3, 2, 1. I'm gonna restart. What is up, Banana Republic? BananaJoe808 with another math tutorial. Today, we'll be determining which intervals make the graph increase, decrease, or remain constant. So let's slip right into it, man. Let's go. Here, I'm gonna bring it down. You can start streaming it. Guys, today we'll be learning how to use the following graphs to determine the interval in which the function increases, decreases, or remains constant, if at all. So let's just hop right into this. Or shall I say, slip right into it. Okay. Here we have problem number 1. So when it means, or when it talks about determining the interval in which the function increases or decreases, oh my gosh, what's up, Ingrid? Restart. Okay. So when we restart. Okay. So to determine what the heck's going on with the graph, we want to see where the graph is going, whether it's going down or whether it's going up. So what I like to do is plot a point where the graph can change in directions. I plot it over here, and I'll draw a line down the graph to showcase how the change is possible. So when we write our answer out, we write it as a point. And since it's going down, reading from the left side first, as we read a book, we read from left to right. We're not in Japan. So we see that the graph is going all the way down. So we can conclude that it is negative infinity. Because it's going down forever. It's a graph. It's probably going to keep going down forever for a while. Now, Banana Joe is going to slip in something crazy. No, not my birthday suit, but -2. Because you see how the graph actually stops at that point, to -2. Now you might be thinking, which 2 are you talking about? The one on the y-axis or the one on the x-axis? The x-axis, because that is our domain. And so we want to plot 2 points for our answer. So we'll pick up where we left off at -2. And now we're reading the right side of the graph, which we can conclude that it continues to go up forever. Seeming as there's no stop in the graph, we are safe to put infinity. Chat, does this make sense? Okay. Anyways. Oh, follower! Let's go. Thank you. Thank you for the follow. Now, you know how the graph... Wait, now we know how to... Wait, let me restart. Okay. Problem number 2. Here we have this kind of wonky graph. Well, I want to say wonky, but again, we know where the point in which the graph changes directions, so we'll plot it. And then we can draw a line down where it's happening, or where the change is happening. Wait, I forgot a major step. I'm going to restart. Sorry, guys. How are we going to find the interval in which the function increases, decreases, or remains constant? Let's slip right into it. Here we have problem number 1. Seems like a beautiful problem. And so we want to determine whether, or not whether, but which interval makes the function... Okay. Wait. Restart one more time. No more restarts. Slip right into it. So, to determine the interval in which the function decreases, increases, or remains constant, we want to take a look at the graph. And so here we have this nice parabola. Looks pretty cool. I'll zoom in a little more. So we want to determine what intervals make this graph increase, decrease, or remain constant. So what that means is what makes the graph go up and down. And when does it go up and down? Which parts does it go up and down? I'll explain right now. So we want to determine when there's a change. So we'll plot a point in which the graph changes from one direction to another direction. And what I like to do personally is draw a line down the middle, because Banana Joe likes to keep it smooth. And so when we answer these types of questions, we want to start off with where the left side of the graph is going. So right here, we can conclude that the left side of the graph has started from negative infinity, because there's no stoppage here. Like, there's no point in where it stops. So Banana Joe's gonna put negative infinity, and then we'll put it to where the direction starts to change at -2. Now, how do we answer the other part of this answer? Bro, I'm actually so trash at this. Wait, hang on. Now that we plotted where the graph changes in direction, let's solve it. So, reading from left to right, we can determine that it starts with negative infinity. And what we also notice, thank you for the support, is that it continues to keep going towards negative infinity until it stops at this point, which is what? Banana Joe says -2. Now, you might be thinking, Banana Joe, which -2 is it? The one on the y-axis or the one on the x-axis? Banana Joe tells you it is the one on the x-axis, because we are looking for the domain of this whole thing, of the whole shebang. So now, we have to answer this in 2 points, because it's not only the left side of the graph, but the right side as well. And judging from what we've seen, the left side seems to go down. So we'll draw an arrow going down, meaning it's decreasing. Pretty cool, right? Not the best arrow drawer, but we'll improve. So now with the second point, we start off where we left off at a whopping -2. And then reading the right side of the graph and judging with our elite math student skills, where would the graph go from there? Infinity. What a smart young man you are, or woman. So we conclude that after it decreases from negative infinity to -2, it starts to increase from -2 onwards towards infinity. Picking up what I'm slipping on? Banana joke. Now on to number 2. We have a little different graph. I want to know what to call this graph, because Banana Joe did not pass high school, but who cares, you know? So we're going to plot the point in which the graph changes, and again, I'll draw a line down the middle to highlight where exactly that change happened. And so Banana Joe, again, reads from left to right, so we notice that it's been going up. And now you might be thinking, wait, it started from the bottom though, so wouldn't it be negative infinity? No, it wouldn't. It would actually be positive infinity, because it's going up all the way towards 1. And now we do the same thing like we did last time. Pick up where we left off at 1, and then you might be thinking, what could this possibly be? Infinity? Negative infinity? I say it's infinity. Banana Joe says that because it's above the domain in which the x-axis is positive, so why would it be negative? From that, we can conclude that from the left side of the graph increases, and from the right side of the graph actually remains constant. Something we haven't seen yet until now, which is pretty cool. Our third problem. Here we have what seems to be a pretty wonky graph. Nothing Banana Joe can't do though. So again, we'll plot our point, and then we'll write down the answer already, because there's no line, there's no change in the graph. We can tell that it's going one way forever. So we can start from where it left off, -2. So we'll write -2 onto infinity. Pretty cool, right? I would like to think so. Banana Joe likes math. Whew. So far, we've been slipping into a lot of awesome things, and with this third problem, is it constant? No, it's actually increasing, because it's slightly goes up, and it's gonna keep going up. You know what I mean? Like my money. On to the next 3 problems. Number 4. Now you might be thinking, how the heck am I gonna graph this? How am I gonna answer this? You don't need to. Nah, I'm playing, you do. Banana Joe's gonna plot the points in which the graph changes, and there's 2 of them. So what does that mean? You gotta plot 3 different answers. So we'll start from left to right, Again, nothing changed. We're reading it just like usual. So we can determine, or we can conclude that it's going up. So we can put infinity up until 0. That's our first part of the answer. That's this part. Second part, you see the graph actually goes down. So we want to put negative. No, you really thought, huh? You're gonna put 0 until what? Is it going down forever? No, it's not. It's only going down to 2. 0, 2. But we do know it's going down. And then the third part of the graph, the part in which it seems like it's going forever. We start at negative 2 and then it goes all the way up to infinity. It's pretty sick. So now we can plot the directions in which these intervals go. Infinite, decreasing, increasing. Didn't mean to say infinite back there, but that's how you do it. Problem number 5. This one looks pretty easy. There's only 2 parts of the graph. It just looks a little different. This part of the graph looks pretty easy. There's only 2 sides of it. So we can still read from left to right. I notice it's going from negative. Nope. It's actually going from positive infinite. Oh my gosh. I can tell that this graph is the same like any other graph, specifically the parabola. So I'm just going to get the plotting. So we can tell that it's going up. So I'm going to put infinity up until what seems to be 0. And then same with this side. I start where I left off at 0 onto negative infinity. Now, you might be thinking, there's a horizontal asymptote. It's not going to go down forever. But it is. It's going to keep going down, but it won't touch 0. So, although the change is very small, you can tell that it's decreasing more and more. Because Banana Joe said so. Problem number 6. Here I'll plot. Actually, no, we'll skip problem number 6. That's kind of hard. Problem number 7. Here we have another parabola, but it's upside down. So what am I going to do? Same thing I always did. Plot my point, highlight the line in which it splits off in directions, and start plotting. Here we can tell that it's been going up. So we can put infinity up until where it stops in direction, which is about 4. Rinse and repeat. You got 4, which is where the direction starts to change, on to negative infinity. How do I zoom out? This is how you do Algebra 3. And this was Banana Joe, the awesomest stream ever. Thank you guys for watching. I appreciate all your time, and your support, and your dedication for watching my very trash stream. That's it. That's literally it. Now I'm going to edit it and make it look professional. I don't know. I could have done a lot of things better. Chat's kind of dead too. I think I'm watching myself. Hello? 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 Well, I don't think anyone's here, so I'm going to redo it again.